Hi, hello everyone. This is your Ameer sir, Master Teacher of Physics, okay, at Vedantu. Now, quickly tell me, how are you all doing? Was it an amazing day for everyone? Okay, for me it was an amazing day. Hi Dhruv, what about you all? So, if okay, so I'm gonna think that yes, you are or you had a super amazing day, right? Okay, so Shamsul, hello, kaise ho? I'm so good. Okay, for me it was like a super busy day. At the same time, I was super active and super happy also. So everything was fine. I think that is visible from my smile, right? So hi Vijay. So just like I said, I think it was an amazing day for everyone. So here we go. Now, as we are starting a new session here, some of you might need to be knowing about myself, right? So I'll give you a quick introduction about myself. So I did my BTech from an IT Calicut, okay, in mechanical engineering, and I'm a teacher in more than 2.5 years and teaching JEE and NEET students, and everything is going quite good and amazing. And I'm from Kerala, so this is a small thing that I want to tell you now. Okay, so I barely know the language Hindi, so I think it'll be better if we keep all the teachings and everything in English, right? And we have some South Indian students also, so I think that's gonna be better, right? So with a smiling face, you're gonna give me a thumbs up for that. Yes, thank you. Sir, aap main bahut badhiya. I don't know whether that Hindi is correct or not, so I just used. Okay, Dhruv. Okay, so let's continue. We know that we are just 60, not 60, oh my god, I use it, we don't have 60 days. How many days we have now for the first JEE mains exam to happen? Maybe approximately, let's say 30 days, right? And it's the high time, so we have to make a quick run through all the topics if we want to score a very amazing mark and to get a top rank, right? So that's why here we are with the launch of Rapid Sprint 2.0, where we will be going through all the topics, okay, before the first JEE mains exam happens. Okay, so for that I'm gonna show you the actual timetable here, right? Give me a minute. So as you can see that this is going to be the timetable for this month. Okay, so today, which is Jan 11th, I'm going to start with electric field, and we also have a Garang sir in the same channel, right? So he'll be starting with 11th standard topics and I'll be dealing with the 12th standard topics. So as is the first session, I'm showing you the calendar of what we are going to do in this particular entire series. So this is the timetable for the month. So I have shown you this is only because you can make your schedule also according to this, and before you come to our classes, okay, you can actually prepare or you can finish your studies, which means the conceptual studies of the same topics. Okay, so that's going to be amazing. So be with us so that we are going to complete the entire chapter before the exam happens. Don't you think it's an amazing opportunity for everyone? Okay, it's an amazing opportunity for me also, because I'm there with you, so that I am able to help you also in the perfect way possible to make this as an amazing success for you. Right? Okay, so let's begin. Before we begin, what I have to show you is that, okay, so all the questions that we are going to discuss, okay, let's say from the today's electric field, right, it will be posted in the Telegram group. So if you want to practice those questions before you come to the classes, okay, you can actually be a part of this particular group here. Okay, so before you come here, you can actually solve the question. If you have any doubts, we'll be clearing it out in the class together, and we're gonna make it super awesome, isn't it? Shamsul, Vishaka, everyone in the classroom. Okay, now one more thing that I have to tell you is, okay, if you actually need a very huge conceptual discussion of each and every chapters, okay, if 11th and 12th, if you need personal attention, okay, and if you wanted to write an all India level mock test, okay, and if you really want to do much of questions which we will be giving you as assignments, you can be a part of JEE or NEET crash course of 2021. Actually this cost 10,000 rupees, but just because you are attending my class, I'm going to give you the coupon code. As you can see, it's AMECC, so you'll be getting just for 8,000. Oh my god, 8,000 for the complete syllabus of 11th and 12th. That's amazing. I'm sure you are going to be there. So here we go with our session with our first question. Okay, So I hope everyone is having a pen and a book right in front of you, because we are going to do super amazing questions. We'll be doing today with we'll starting with theoretical questions today, and from next class onwards, fine, okay, we'll be having the objective like questions, fine, okay. So Prasanna, so here we have, so everyone be with me and let's go through the first question. So 4-point charges, okay, so at the point A 2 microcoulomb, at the point B we have -5, at the point C we have 2, and at the point D we have -5, right? Okay, all are microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? I hope you all got it, which means this entire question is about the forces regarding, right? So how can we actually calculate the force that exists between two charges where there is a distance between them? What do we have? Yes, we have the Coulomb's law or the Coulomb's force. What does it say? According to the Coulomb's law, if you have two charges, 1 minute, okay, now let's write. So if you have two charges, let's say Q1 and let's say Q2 we have, where there is a distance of r between them, the force that exists between them is equal to K Q1 Q2 divided by r square. This is the magnitude of the force, right? And how can you measure, or how can you find out the direction of the force? So between the same charges it is going to be repelling, and between the opposite charges it's going to be attracting. So you can choose a direction accordingly. Fine, so we are going to apply the same thing over here. Okay, so I hope everyone is in the same page and everyone is with me. So let's start. So according to the question, let's name the points as A, B, C and D. I hope you can see the screen, right? Though I'm not visible, though no, I'm not the important person here. So at the point here we have 2 microcoulomb, right? At the point B we have -5 micro, and at the point C let's call this as 2 microcoulomb, and at the point D we have -5. Okay, it's microcoulomb. So we are keeping 1 microcoulomb or 1 coulomb charge. What do we have? Yes, 1 microcoulomb it is. Fine. Okay, exactly at the center, right? So the question is, what is the force it experiences? Simply, what is a force? So we can use this formula of K Q1 Q2 by r square. So to the center, let's call the distance from all the corners to the center, let's call it as A, right? It's a center point. So if I write the force experienced between -5 and this 1 microcoulomb, how much it is going to be? That's going to be, or let's call it as a force provided by A on the center point, we call it as O, right? Okay, what is the force going to be? That is equal to K, Q1 is 2 into 10 power minus 6, right? The second charge which is kept at the center is 10 power minus 6, which is 1 microcoulomb. I think you all know the conversion, right? Okay, the microcoulomb is 10 power minus 6 coulomb. Very good. Now r square. So here we have A as a distance, so A square, right? So this is the force. And what is the direction of force going to be? This 2 microcoulomb, this 1 microcoulomb, it is going to repel this. And similarly, we can find out that the force given by C on the point O, okay, how much it is? That's also going to be K, Q1, Q2 by the same thing, which means the magnitude is going to be the same. What about the direction? This is 2, it's going to be repelling like this. So, equal and opposite forces, it will cancel. So, do I really need to explain the second part of the question? Do I really need? I don't think so, because I'll give you a brief part of it, because this 5 microcoulomb with a force will be attracting this towards, because this is minus and this is plus, and similarly with the same force, because we have the same charge and the same distance, this -5 will be attracting this 1 microcoulomb towards it, right? So equal forces again, opposite direction, it's going to get cancelled. So what is the net force going to be? It's very simple. Who's going to answer me in the chat box? Anyone? Right? So here we will get the force as 0, right? Okay, very good. Board sprint, first we are going to come across the JEE, right? So let's complete that. Prasanna, okay, so be with me, don't worry, we are going to soon start with the board sprint also, don't worry at all. If this question is clear, we can move to the next one. What do you all say? Is it clear from everyone? Is it clear from everyone? Right? Prasanna? Vijay? Okay, so I'm going to move to the next part, right? So here we have the next question. So this question, let me tell you, this is also based on what? This is also based on the Coulombic forces. So let's do it. 3-point charges, okay? So instead of 4, here we have 3, are kept at the vertices of an equilateral triangle of side A. The question is, determine the magnitude and sign of the charge to be kept at the centroid of the triangle, right? So that the charge at the vertices remains in equilibrium. Fine? Okay, so let's go with it. So let's do the pictographical representation, right? So here we are. Okay, 1 minute. Yes. So here we have the equilateral triangle. I think it will be a better picture, will be more clear to look. So here we have the equilateral triangle, each are 60 degrees. Okay, I don't need to mention that. So here we have 3-point charges plus Q kept at all the vertices, right? Okay, so it is regarding the force experienced by the charges kept on any of the vertices. Okay, so let's consider one of the vertices here, right? Which means let's call it as the point A. And here we have the centroid O, right? If I mark this as the point A, right? Okay, and if I take this point A with the plus Q charge, let's find out the total force existing on this plus Q charge because of the other charges kept at the point B and C, right? Just the Coulombic forces. What is the force experienced on A because of B? F on A because of B is equal to K Q1 into Q2, both are of the same charges, Q square divided by the distance is A square. Okay, is in the magnitude of the same given by the point C on A, right? Right, so the magnitude of the forces are the same, but the only thing is the direction is different because this plus Q will be repelling along the line joining them, and similarly this plus Q charge is again repelled by this charge which is kept at the point C. So there is a difference in direction with the same magnitude of F, let's say. And what is the angle? Here it is a 60 degree. Here also it's going to be 60 degree. Right? Okay. Now you have two vectors of equal value making an angle of 60. How will you calculate? The resultant is equal to root of A square, which is F square, plus F square, right? To first vector into second vector, both are F itself. You can see that both are having the same magnitude, okay, into cos of 60. Let's make the calculation faster. Cos 60 is equal to how much? 1 by 2. 1 by 2, this 2 cancel. F square, F square, F square. Okay, it is a root of 3F square. F square will come out of the root. So I'm writing it as F root 3. What's the value for the force? Here we have written that is K Q square by A square, right, into root 3. So this is the net force experienced by the charge Q kept at the point A, or any of the vertices you take, okay, or any of the charges which you take which is kept at the vertices, the forces that I experience will be the same. But the question is, what should be the charge kept on the centroid so that the net force on each of the charges will be equal to 0. Okay, so if you want to cancel this force of kq square by root 3a square, what is its direction going to be? Obviously it is going to be in the perpendicular bisector direction. Why? Because it is two equal forces, so the resultant is going to be in the direction of perpendicular bisector. So the force given by the q dash, which is kept at the centroid, should be producing an equal magnitude of the forces and in the opposite direction, right? Okay, so if it is in the opposite direction, what should be the sign of the charges? Now it became very easier. The sign of a q dash, sign equal to how much? Negative. We got that, right? Without any issues. Now what is it? Now it's the problem of finding out the magnitude, right? We know that from the vertex for an equilateral triangle to the centroid, we all know that if this is A, this is going to be A by root 3, Okay, no doubt in that, I suppose, right? So what is the force experienced by Q because of this Q dash magnitude? Let me write it here, right? So the force experienced by A because of O is equal to K Q into Q dash divided by, what's the distance? A by root 3 the whole square. So it's A by root 3 the whole square. So root 3 square, if it comes to the numerator, it's 3K Q dash by A square. Now, if you want to have the net force as 0, this downward force should be equal to the upward force with the value of root 3 K Q square by A square. Right? So we can cancel off A square, K can be cancelled, right? Root 3 and 3 will cancel and 1 root 3 will be remaining here. 1Q will be cancelled off. So you have 1Q here and Q dash is remaining. So Q dash is equal to, simple, right? So this is it, and this is how you do this problem. I hope it is total clear. I have explained the entire theory, right? President Akhil, Robert, Santosh, Vijay. So we have went through the theory in detail. Like I told you, whenever I deal with a question, we'll be doing it in a complete manner by going through all the theories. So shall we move to the next? Right? Okay, so I'm going to think that you don't have any doubts with this. Okay, because we have went in detail. So let's jump to the next question. Okay, Santosh, Prasanna, yes. So shall we read the next question together? Two charges plus and minus 10 placed at 5 millimeter apart. What do you call this? Two equal charges of opposite signs kept at a distance between them. We call it as dipoles. Right, okay. Determine the electric field at, so we have two questions, at point P on the axis of the dipole 15 centimeter away from its center O on the side of the positive charge. Let's do it, then we'll be jumping to the next. Fine. So we have two charges. This is which are it? Yes. 1 minute here again we go. Okay. Yes. Okay, so there was some confusion in it, right? So a lot much of technical things has to happen here. So let's write down whatever it is given here. So we have a minus 10 charge, okay, 10 microcoulomb, let's say that. So let's not make a mistake. So minus 10, and we have a plus 10 microcoulomb where the distance between them is 5 millimeter. So on the axis, okay, we have a point P or O, yes, P from the center O, which is a 15 centimeter, right? So the question is, what is the value for electric field at the point P because of this dipole, and the point P is an axial. We can see that the distance from the center, which is 15 centimeter, right, is much greater than the 5 millimeter. So what is the equation for the electric field on the axial point created by a dipole in this case? Let me write it here. Electric field is equal to 1 by 4 pi epsilon 0 2p by r cube. Is anyone having the doubt of what is this P actually? P is what? The electric dipole moment. You calculate it by one of the charges into distance between them. So that's it. An electric dipole moment, okay, for your more information, it's a vector quantity. It is directed from negative towards the positive. So making it more clear. So let's start substituting here. So this is equal to, what is 1 by 4 pi epsilon 0? 9 into 10 power 9 into 2 into P. Like I said, it's a dipole moment with the value of one of the charges, 10 microcoulomb, into what is the distance? 5 millimeter. That's 5 into 10 power minus 3 divided by r cube. What is r? R is 15 centimeter or a 0.15, the whole cube. Okay. So now you have to do the mathematics here, right? So how much we are gonna get? 1 minute. My mic just jumped out. Okay, so we are going to get a value of around, let's say, 2.67 into almost 10 power 5. Okay, because I knew the answer already, so I don't think that I'm a superman to do the calculation this fast. Actually, you can do it, okay, once you become a super pro in mathematics. That's why it is told to you by all the teachers not to use the calculators at any point of time, because you have to slowly increase your pace of doing the mathematics part. So this is it, right? And what is the direction going to be? Because we are talking about electric field, which is a vector. So we know that this 10 at the point P will be producing an electric field away from it. As it is more closer to it, the value for the electric field produced by positive will be greater compared to the electric field produced by minus 10 at the point P because of its larger distance. So the net electric field will be in the direction of the positive charge, so it's going to be away. Now, second part of the question. 15 centimeter from the point O on a line passing through O and normal, which means at the perpendicular bisector or at the equatorial point where the distance is 15 centimeter again, right? What is the value for electric field? What do you have to do? Simply use the equation here. What is the value for electric field? Let's write it, right? It is 1 by 4 pi epsilon 0. Instead of 2p, it's p by r cube. Okay, so it is only p by r cube. 1 by 4 pi epsilon 0, 2p by r cube was 2.67 into 10 power 5. So p by r cube will be half of it, which means 2.67 into 10 power 5 is 2p by r cube. You want only p by r cube, so it is by 2. So you'll be almost having a value of let's say 1.33 into 10 power 5, right? Okay, so this is, and I hope you know the unit, right? Newton per coulomb here, Newton per coulomb here, if I forgot to mention the electric field in the previous question also. So is this clear, everyone? So here we have covered one more topic from the part of electric field. Is it super clear to everyone? Yes? No? Yes? Okay, so I'm going to really think that you all understood without having a single doubt. So it's the time for next question and we are going to jump for it. Where is it? Okay. This is a beautiful question, right? This is completely based on Gauss law. An electric charge Q is placed at one of the corner of a cube. So let's draw the cube first. I'm not a big drawer here, so let me draw the cube. Let me try drawing it. So yes, so we successfully completed in drawing a cube here, right? So what has done is, or what is given here is, at one of the corner we are keeping a charge. Let's say I'm keeping a charge here, right? So you have a charge Q. Now the question is, what will be the electric flux? I hope you remember the Gauss law. According to Gauss law, it says the total amount of electric flux passing from a charge Q is given as how much it is. Let me write it here. So that is equal to 1 by epsilon 0 times the total charge. So these are the total electric field lines passing from a charge Q. The question is, how much of that, which is Q by epsilon 0, is passing through this particular Q? If it was a uniform cube, right, or if this charge Q was uniformly kept on this cube, we can say that it is divided in a uniform manner, but it is kept on a corner. We cannot do that. So what we have to do is, in order to understand the amount of flux passing through this cube, you have to keep this charge in a uniform manner, right? Okay, so how can we do that? We can create or keep 8 such cubes around it. I'm not a great drawer, so you will say that one is kept here, one is kept here, one is kept here, one is kept here. Okay, it will constitute the bottom part. On the top part also 1, 2, 3, 4. Right? So exactly you can have that charge in between or exactly at the center of 8 such cubes. Can you actually imagine that? Everyone? right? Okay, so the total flux, which is q by epsilon 0, is part of those 8 such cubes. So through this particular cube, right, which is one of the 8 cubes, right, how much will be passing through that? Vijay, how much will be passing, right? So through this particular cube, okay, the flux passing through a single cube is equal to 1 by 8 times q by epsilon 0. This is it. So we have tried to cover a maximum number of questions. Other than just doing questions, we were mainly concentrating on the concept. So we are going to continue with it, right? I hope you all enjoyed without having any doubts, with a smiling face, isn't it? Yes. So with that hope, now what I'm gonna show you is, right? So I know that you all really love the session, right? So what you have to do, you can do small things which can actually consume 30 seconds of your life, okay, for me to take such a big initiative, okay, and just for your compliments, the way of you giving compliments for what I did, what you can do is just click on the like button, which you can see exactly at the bottom of the video which you're watching, okay, and if you think that your friends are also going to get benefited, please don't hesitate to share. And the last thing, if you really want to get the notification from this particular channel whenever me or the ground star go with a sprint series, don't forget to subscribe. It is going to give you the notifications, right? So now having this give and take policy, right, so V2 will be coming with the classes. You can keep on subscribing, so that's a small thing you can do for all of us. So thank you so much, I must say, for the time being, okay, and tomorrow we'll be meeting. Not tomorrow, I think it is on Wednesday at 6 o'clock, right? So yes, at Wednesday 6 o'clock we'll be meeting with a new chapter with so much of amazing objective questions from the chapter of electric potential. So you can come prepared. Questions will be uploaded in the Telegram channel, okay? So be there, active in the Telegram channel, and come here and let's rock the session. So bye everyone, till we meet next time, and take care and good night.